Hello, and welcome back to Summer Work Help for Calculus 1. In this video, we're going to be taking a look at question number 17. Question number 17 says, without using a calculator, evaluate the following. And there was a hint to use question number 14. Well, question 14, as you may remember, was the complete unit circle. So we went ahead and we filled that in just using our brains, not not looking it up, but sort of figuring out what are the degree measurements, what are the angle measurements, what are the XY coordinates, looked at some of the patterns that exist. And so in this question, we're going to be evaluating each of these trig functions. So let's get into it. All right, 17a. So 17a is we want to evaluate the sine of 30 degrees. So if I were being asked to evaluate this, first thing I would do is either in my head or maybe just a quick sketch, all right, whatever you find to be most helpful. Think about where is 30 degrees on the unit circle, all right? So we could go ahead and look up on question 14, but also just a kind of a handy thing to remember about the unit circle is that with degrees is that the first angle that you run into after 0 degrees is 30 degrees. So it's like right there, all right? So that's what 30 degrees looks like in standard position. All right, it's kind of close to the x-axis, just a little bit above it. And I want sine. So I'm going to be thinking about the xy coordinates that exist at 30 degrees. Well, at 30 degrees, the triangle that gets formed here, and this is x and this is y, my triangle is a wide, short triangle. So I go pretty decently far to the right, but then I don't go up very much. And as we saw when we were filling out the unit circle with question number 14, in this situation, the choices for x and y are, well, it's not 0 and 1 because those only occur on the axes. It's also not root 2 over 2 because those occur when those occur in the middle, and those angle measurements end in a 5 with degrees. So my only choices here are 1/2 and root 3 over 2. It's just a question of which one's which. Because I have a wide, short triangle, it means that my x coordinate is going to be the larger number, and my y coordinate is going to be the smaller number. Now, what I need to remember for this is that sine is your y coordinate, and cosine is your x coordinate. So we gotta remember that. So if I want the sine of 30 degrees, it's my y coordinate at 30, and because it's a short triangle, it is the smaller of the possible values, which is 1/2, and because I'm going up, it's positive 1/2. So sine of 30 degrees equals 1/2, and we didn't use anything other than our brains to answer that question. All right, we didn't even have to refer to the complete unit circle, even though we completed it. We could just sort of think through, what does 30 degrees look like? What are the x and y coordinates? What do they look like? What does sine refer to? And we're able to get 1/2. Part B. Part B is asking for the cosine at 225 degrees. So again, either in your head or maybe as a quick sketch off to the side, think about where does 225 degrees, where does that appear on the unit circle? Well, this ends in a 5, which means it's one of your middle angles. It's going to be right smack dab in the middle of a quadrant. 180 degrees is right there, and 270 degrees is right there, which means 225 is going to be right there. So that angle right there, that's theta, okay? That's 225. Say 225, right? Okay, so on the unit circle, I've got some xy coordinates here, some xy pair, all right? And notice that we are, like I said, this angle ends in a 5, so it's right in the middle. And when it's right in the middle, your xy coordinates, write it here, write it a little bit larger, put it here. When you're right in the middle, your xy coordinates, that's where you see the root 2 over 2 in both. Okay, so both x and y are root 2 over 2. And in quadrant 3, notice that from the origin, I go to the left and then I go down. Well, because I go to the left, it tells me that my x-coordinate is negative. And because I go down, it tells me that my y-coordinate is negative. So actually what's kind of nice about this problem is that even if you forget which one is which, like sine and cosine, like x versus y, you're actually still going to get the correct answer because they're both negative root 2 over 2. However, it is worth remembering and sort of recognizing that cosine is my x coordinate, which means specifically I'm talking about the first number there. I'm talking about the negative root 2 over 2 that comes from going to the left because cosine is x. So my final answer here is going to be negative root 2 over 2, and that is my exact answer. Note that if you tried to use the calculator on this one, you would get an ugly decimal. You'd get like negative 0.707 or something like that. That's not exact. So cosine of 225 degrees, if you have an exact answer, it's got to be negative root 2 over 2. All right. Now, if you need an approximate answer, then fine, right? But this is the exact answer for cosine of 225. Okay, C. I want the tangent of pi. So there's no degree symbol here. Plus, as we've seen, pi commonly is used for radian measurement. I probably could have mentioned that back when answer or question 5, when it was like, what do you know about pi? You could have said that pi is commonly used to represent radian measurements. We forgot to mention that. So I want to know, what is the tangent of pi radians? Again, either in your head or off to the side. Try to visualize, where is pi radians? Well, the one conversion that you do need to know is that pi radians is 180 degrees. Right? So that conversion from pi radians to 180 degrees, we do want to know that. That is the key conversion factor between radian measurement and degree measurement. So no matter how you look at it, either as pi radians or 180 degrees, we're going to be right there. And I'll do this in blue so it stands out, maybe. Okay. So we are on the negative x-axis, right? And our coordinates are, say, like right there. And I want to know, what are my x and y coordinates at pi radians? Well, notice that I'm on the x-axis. So if I want my x coordinate from the origin, I just went straight to the left, and I didn't go up or down at all, right? And then again, that's on the unit circle, right? So I don't feel like drawing. The unit circle is going to add too much information here, but I'm on the unit circle. And again, by definition, the unit circle has a radius of 1. So if I just go straight to the left and I don't go up or down at all, it means that my x-coordinate is negative 1. And because I didn't go up or down, it means that my y-coordinate is 0. So those are the coordinates that I'm dealing with here. That's x and y. So if I want the tangent of pi, well, here's where you're going to have to remember, like, how do I express tangent in terms of sine and or cosine? And tangent is sine over cosine. And that's pretty foundational to trigonometry. So at this point, you really, quote, should remember that tangent is sine over cosine. Another thing that we need to know here is we need to know that sine is my y coordinate, and cosine is my x coordinate. So my y coordinate at pi is 0, and my x coordinate at pi is -1. So I've got 0 divided by -1, which is 0. So the tangent of pi equals 0. Quick side note here. Note that the domain for both sine and cosine is all real numbers. So that means the graph of sine and cosine, it's one continuous wave, and there's no gaps, there's no vertical asymptotes, nothing like that. However, the other 4 trig functions, the domain is not all real numbers. Okay, there are some values that result in undefined. And you can see here that if we had found, say, like the tangent of, if we found the tangent of pi over 2, we'd be here, and that's 0, 1. And you can see here that if you try doing the tangent of that, you're going to get 1 over 0, which is undefined. So even though sine and cosine are always defined, all right, the domain is all real numbers, the other 4, sometimes you can get undefined. Now, we did not get undefined this time, all right? But if we had wanted the tangent of pi over 2, that is undefined because it would be 1 over 0. Likewise, if we wanted the cotangent of pi, well, the cotangent of pi would be cosine over sine, and then cosine would be -1, sine would be 0, so you get -1 over 0, which would also be undefined. So just recognize that it is possible to get an undefined value for tangent, cotangent, secant, or cosecant. It's not often, right? It's normally defined, but there are some values that do result in a 0 in your denominator, and so those are going to be undefined. But our final answer for C is 0, because tangent is sine over cosine, so it's 0 over -1. All right, D. I'm going to erase some of the stuff from before just to give us full amount of space. All right, so for D, we've got the cotangent of 3 pi over 4. All right, before I do anything else, I want to just figure, I'm going to ignore the cotangent for a second, and I just want to get a good understanding of where is 3 pi over 4 on the unit circle. So ignore cotangent and just where is 3 pi over 4? All right. When we were doing question 14, which is filling in the unit circle, I told you that the degree measurements that end in a 5 are going to be right smack dab in the middle of each quadrant. I also said that in terms of the radian measurement, those are the angles that have a denominator of 4. So if you have a radian measurement that's like of this form, where it's like something pi over 4, well, those 4s occur right in the middle. Another way of looking at it is a 4 means 1/4. So when you're at 1 pi over 4, you're here. When you're at 3 pi over 4, you're here. When you're at 5 pi over 4, you're here. And when you're at 7 pi over 4, you're here. And then like 2 pi over 4 simplifies to 1/2. 4 pi over 4 simplifies to 1, right? So I'm talking about the ones that don't simplify. So the 3 pi over 4 is in quadrant 2. That's right here. So 2 pi, so again, 1 pi over 4, 2 pi over 4, 4 pi over 4, right, which simplifies to just pi, and this simplifies to, oh, this should be 4, my bad. So this simplifies to just pi over 2. But then 3 pi over 4 is you're right in the middle of quadrant 2. So as we said for part B, when we were looking at 225, now for part D, we're at 3 pi over 4. And again, when you're in the middle like this, your xy coordinates, this is where you end up seeing the root 2 over 2. Like that. Now, in quadrant 2, to get to quadrant 2 from the origin, you go to the left. So that means your x-coordinate is negative. But then you go up, which means your y-coordinate is positive. So my coordinates at 3 pi over 4 are negative root 2 over 2, comma, root 2 over 2. And if you go and check number 14, you'll see that those are, in fact, the coordinates that we found. So now, for the first time in this question, we're going to deal with cotangent. So cotangent, well, there's a couple ways of thinking about cotangent. One way of thinking about cotangent is that it's 1 over tangent. Okay? So you could think of it that way, but then you have to get tangent. And then for tangent, you have to think of like sine and cosine. So I would actually encourage you for this question to just go straight to thinking of sine and cosine. So just like tangent is sine over cosine, cotangent is cosine over sine. Okay. So again, all 6 trig functions can be expressed as some combination of sine and or cosine. So cotangent can be expressed as cosine over sine. So I want cosine of 3 pi over 4. That's going to be my x-coordinate. So my x-coordinate, as we just said, is negative root 2 over 2. And then that's over sine of 3 pi over 4. And that's my y-coordinate, which is root 2 over 2. So now I have a complex fraction, and that might look a little intimidating, and sometimes complex fractions can be intimidating. However, what's nice about this one is that you basically have something over itself. The only difference is that negative, all right? Well, whenever you have a negative inside a fraction, but you only have one of them, like either your numerator or your denominator is negative, but not both, anytime one of them is negative and one of them is positive, just pull it out front in front of the fraction. Just make the whole fraction negative. Don't leave the numerator negative with a positive. Don't leave the numerator positive like a negative denominator or vice versa, right? Just make the whole fraction negative. So you pull the negative out front, and now you really do have something over itself. You've got root 2 over 2 over root 2 over 2. And that happens at your middle angles, right? Because that's when you see the root 2 over 2s a lot. Well, that's exclusively where you see them. So I have something over itself, which is 1. So my final answer here for D is just negative 1. Because it's negative root 2 over 2 over root 2 over 2. So that simplifies to negative 1. And the reason why we got those is because, again, when you're in a radian measurement, if it's something pi over 4, that's when you see the root 2 over 2s, because that's when you're at, right in the middle. It's, 45, 135, 225, 315. That's when you see this root 2 over 2 value. So that's our final answer, negative 1. All right, E. So for E, we've got the secant of 300 degrees. Again, kind of like D, I'm going to completely ignore the fact that we're dealing with secant for a second, because that's not going to do you any good if you don't know where you are. You got to figure out where you are first, then you deal with evaluating the trig function. But we just got to think about where is 300 degrees on the unit circle. Well, a full circle is 360. I think just about everyone hopefully knows that a full circle is 360 degrees. And then if you go just straight down on the y-axis, well, that's 270, because it's like 90, 90, 90, right? So 3 90s bring you to 270. So that's kind of how I think about that angle. So when you're dealing with an angle like 300, well, spoiler alert, 300 is between 270 and 360. So it stands to reason that we'd be in quadrant 4. All right, and we are. We're somewhere in quadrant 4. Now, 300. Well, notice that 300 is 30 off of 270. So 300 is not in the middle, right? It doesn't end in a 5. And it's closer to 270 than it is to 360. So when I'm thinking about what it looks like, I'm thinking of something like that. okay? It's in quadrant 4, and it's past 270, but it's not much past 270. It's not in the middle, and it's definitely closer to 270 than it is to 360. So it's closer to the negative y-axis than it is to the positive x-axis. All right. So this angle right there is 300 degrees. Okay. So just like always, I've got my xy pair at that angle. And I'm not on an axis, so I'm not going to use 0 plus or minus 1. I'm also not in the middle, so I'm not going to use plus root 2 over 2 plus root 2 over 2, which means my only options here are some combination of 1/2 and root 3 over 2. Right? And it's going to be one of each, right? So you never use both at the same time, right? They're never both going to be 1/2 or both be root 3 over 2. So at 300 degrees, one of these values is 1/2, and one of these values is root 3 over 2. So if you think about the triangle that gets formed here, it's a right triangle, just goes straight down. Notice that this triangle, this is a skinny, tall triangle, right? I didn't go very far off of the negative y-axis, right? So my horizontal distance that I've traveled is relatively small because it's a skinny triangle, and my vertical distance is large because it's kind of tall. So that means that my x value is the smaller value, that's the 1/2, and then my larger value is root 3 over 2. Because it's a skinny, tall triangle. Now, I'm in quadrant 4. In quadrant 4, from the origin, to get to any xy coordinate in quadrant 4 from the origin, you're going to travel to the right, which means your x value is positive, but then you're going to go down, which means your y value is negative. So my xy coordinates here are 1/2 comma negative root 3 over 2. Great. Now, for the first time in this problem, now I'm going to think about the secant function. In order to think about this, in order to get this answer, or evaluate this, you want to connect secant to sine and or cosine. Well, the reciprocal identities tell us that secant is the same thing as cosine. The reciprocal of cosine, right? So the reciprocal of cosine is secant, and the reciprocal of secant is cosine. They have that relationship, right? So I can think about this in terms of 1 over the cosine of 300. This is where you're going to have to recognize that cosine is x, right? So cosine is x and sine is y. So I took a look at what I just wrote, and the x coordinate at 300 degrees is 1/2. So I've got 1 over 1/2. All right. Way back in question 1, we looked at a whole bunch of different arithmetic/algebraic properties. And one of them was that when you have a complex fraction like this, when you have 1 over a over b, and when the big denominator is itself a fraction, what happens is that flips the fraction. So 1 over a fraction flips it, and it becomes b over a. Well, this is exactly what I have here. I have 1 over a fraction, and that fraction is 1/2. So what I'm going to do is I'm going to flip the fraction, so it becomes 2 over 1. Well, 2 over 1 is just 2. And that's my answer. So again, start to finish, I ignored the secant, and I just focused on the 300 degrees. And I said, all right, what does that look like? 300 degrees is between 270 and 360, so I'm in quadrant 4. It's not much beyond 270. It's only 30 degrees off of 270. So it's going to be closer to the 270, which results in a skinny, tall triangle. So my x-coordinate is the smaller value, which is 1/2. The y-coordinate is the larger value, which is negative root 3 over 2. And it's negative because I go down. Secant is 1 over cosine, which means it's 1 over 1/2. When you have 1 over 1/2, you flip the fraction, so it becomes 2 over 1, and 2 over 1 simplifies to just 2. And so my final answer for 17E is 2. Secant of 300 degrees equals 2. Part F. Part F is asking about the cosecant of 3 pi over 2. Just like the last couple problems, I'm going to ignore the trig function itself. Like, we're going to eventually deal with the cosecant, but not until I got to figure out where we're at first, all right? Because if I don't know where we're at, I'm not going to be able to figure out what's happening with cosecant. So 3 pi over 2. This is obviously in radian measurement. Notice that you have to know that pi radians is 180 degrees. So pi radians gets me to about half, gets me exactly halfway around the circle, and then 2 pi gets me one full circle, right? So pi looks like that, and 2 pi looks like that. So pi is half a circle in radian measurement, and 2 pi is one full circle. So what I have here is I have 3 pi over 2, which is 1.5 pi, right? So 3 over 2 is 1.5. So it's more than pi, but it's less than 2 pi. It's right in between. So 3 pi over 2 occurs right here, right there. This angle measurement is 3 pi over 2. Pi over 2 is 90 degrees, so it's pi over 2 plus pi over 2 plus pi over 2. Well, that's 3 pi over 2, getting me to what is equivalent to 270 degrees. If you're more comfortable using degrees, if you can somehow convert into degrees and then answer the question, that's actually okay. So if you don't want to deal with radians, but you can convert 3 pi over 2 radians into degrees and get 270, well, then just answer the question in terms of 270, because it's the same angle, they just look different. Okay, so I'm on the negative y-axis, so I'm here. And at that point, I have, on the unit circle, I've got an x-coordinate and I've got a y-coordinate. Well, my x-coordinate, notice that from the origin, I went straight down, and I'm still on the y-axis. I'm not even in a quadrant, technically. I'm between quadrants 3 and 4. All right, this is 3, this is 4. So I'm not even in a quadrant. I'm just straight down. And again, by definition, on the unit circle, your radius is 1 unit. So if I start at the center of the circle and I just go straight down, and then I hit the circle, well, that means I've traveled a unit of 1. So my y value is 1. And then I didn't go left or right at all. And so my x-coordinate is 0, because I'm still on the y-axis. So my x-coordinate, oh no, sorry, this is backwards. This is backwards. So it's my x-coordinate that's first. So again, I didn't go left or right. Yeah, I was talking about y first. That's why I put that in the wrong spot. I didn't go left or right at all. So my x-coordinate is 0. And then, as I said, we went straight down. So my y-coordinate is 1. And because I went down, it's negative. So the xy coordinates at 3 pi over 2 radians are 0, negative 1. Now, for the first time in this problem, we're going to think about what does cosecant refer to. And one of the reciprocal identities that you're going to want to know, especially when you're dealing with something like cosecant, is that cosecant is 1 over sine. All right, that is the reciprocal identity involving cosecant and sine, is that those two trig functions are reciprocals of each other. So I want 1 over the sine of 3 pi over 2. Sine is your y coordinate, right? So this is x, this is y. So I've got 1 over my y coordinate at 3 pi over 2 radians is negative 1. So we've got 1 over negative 1. Well, you bring the negative out front, then you got 1 over 1, so that's obviously just negative 1. So final answer for cosecant of 3 pi over 2 is negative 1. And notice that we were able to do that entire question. We were able to do all of 17, not only without using a calculator, but we actually didn't even refer back to the unit circle that we filled in. I mean, we filled it in, so we could refer to it. Or you can just sort of like reason through it. And notice that every single time you figure out where are we on the unit circle, right? Are we in a quadrant? Are we on an axis, right? And then given what we know about the unit circle, uh, sort of like what can we tell about the x, y values, right? Are they positive? Are they negative? And again, your choices are 0, plus or minus a half, plus or minus root 3 over 2, plus or minus root 2 over 2, and plus or minus 1. You've only got 9 choices for all of your x, y coordinates. And we just able to figure it out. And that is question number 17.